All right, so problem number 11. We are supposed to write equations for S and T, and then we are supposed to find them. So I'm going to circle my angle, 33 degrees. This is where I'm standing. And I'm going to label my triangle. Oh, that right angle mark kind of moved. He should not be up here. The right angle is right here. So S is my hypotenuse. T is the opposite side. And so 18 down here is the adjacent side. If we want to find S, we need the hypotenuse. And I know the adjacent side. So let's think about SOHCAHTOA for a moment. SOH, CAH, TOA. We want the hypotenuse, so I need either sine or cosine, so I'm not going to use tangent. And I know the adjacent side, so that means I'm going to have to use cosine. So my equation would be cosine of my angle, which is 33 degrees, is equal to the adjacent side, 18, over the hypotenuse, which is S. So there's my equation. And then I would need to actually go through and find S now. So I would multiply both sides by S. So I would have S times the cosine of 33 degrees is equal to 18. And then I would divide both sides by the cosine of 33 degrees. (18) divided by the cosine of 33 gives me 21.463. So that's how I would find S. To find T, T is my opposite side, and I know the adjacent side. So opposite and adjacent means that I would be using tangent. So the equation to find T would be tangent of 33 degrees is equal to opposite, which is T, over adjacent, which is 18. To solve that for T, I would multiply both sides by 18. So I would have 18 times the tangent of 33 degrees. And I would type that into my calculator to find T. And I get that T is 11.689 when you round it out to 3 decimal places. What else would you guys like to see? Yes. 15? 14, absolutely. Number 14. If I go too fast, please let me know. If I need to go back to anything, please let me know. Mrs. James is flying a plane to the Indianapolis airport. So my really bad airplane picture yet again. She is 27 miles ground distance away from the airport, and the runway is at an angle of depression of 18 degrees. Okay, so the airplane is up in the air. I don't know how far. She's trying to get down here to the runway. This is forming a right triangle. It says it is 27 miles ground distance, so that's why I have it along the bottom here. It says the angle of depression is 18 degrees, so that's going from a horizontal down like this. So this is 18 degrees. The angle of depression and the angle of elevation for the alternate interior angle are going to be the same. So this angle down here by the runway is also 18 degrees. We want to know the elevation of the plane, so we are looking for this over here. So I'm going to circle my angle. I'm going to label my sides based on standing at this angle. This side over here is the hypotenuse. We don't know how big the hypotenuse is, and we're not looking for it. We are looking for the elevation of the plane, which is our opposite side over here. And we have the adjacent side, which is 27 miles. So SOHCAHTOA, we do not have the hypotenuse, and we're not trying to find it. So we're not using sine, we're not using cosine. It means we're going to use tangent. So tangent of our angle, which is 18 degrees, is equal to opposite over adjacent. Opposite is what we're looking for. Adjacent is 27 miles. So then we're going to multiply both sides by 27 because that is our denominator. It's going to cancel my denominator here, leaving the x all by itself over there on the right-hand side. When I do 27 times the tangent of 18 degrees, I get 8.773 when I round it to 3 decimal places, miles for the elevation for x. You could write this out in sentence form, says the plane is flying at an elevation of 8.773 miles, or as long as you have it labeled on the picture what you are finding, you could leave your answer as just solving for x. But I do need to see either on the picture or in words what it is that you are finding. What else would you guys like to see? Yes. 17? Absolutely. Which one? 18. Yep, not a problem. Switch gears and go to number 18. Triangle PQR is an equilateral triangle. What does that mean? All sides are equal. It says that PQ is 13. So how big is PR then? 13. And QR is also 13. All the sides are the same. What else is going to be the same in this triangle? Has 3 congruent sides and 3 congruent angles. So angle Q down here, angle R, and the entirety of angle P up at the top. How big are all 3 of those angles? 60. So up at the top, it takes this 60-degree angle and it cuts it into 2 30-degree angles. We have been asked to find the length from Q to S and the length from P to S. They have PS drawn in here and they're showing us that it's forming a right angle. This spot S at the bottom, because it's an equilateral triangle and PS is an altitude, it's also an angle bisector, and it is a median. It is splitting the bottom QR in half. So how big would it be from Q to S then? 6.5. You could do 13 over 2 or 6.5. I would take either one. And then from P to S, this would be our long leg of a 30, 60, 90 triangle. We know that this side is 13. This side is 13 over 2 or 6.5. And this is our long leg. For the long leg in a 30, 60, 90 triangle, that is the short leg times the square root of 3. That short leg is 13 over 2, or 6.5. Remember, we only multiply to our numerator when we multiply something that is not a fraction. So in its fraction form, this would be 13 square root of 3 over 2. Or you could write that as 6.5 square root of 3. I would accept that as correct also. When you take an equilateral triangle and you cut it in half down the middle, you turn it into a 30, 60, 90 triangle. You have to know your 30, 60, 90 rules and your 45, 45, 90 rules. Yes, dear? 19, absolutely. Lindsay is standing at the top of Chase Tower, 700 feet above downtown Indianapolis. Do we know anything about how tall Lindsay is? Does it tell us anything about how tall Lindsay is? Nope. So unlike the homework where I had to add the person's height onto it, I'm just going to use 700 because I don't have any information about how tall she is. So this side of the triangle will be 700 feet. Looking down with an angle of depression of 28 degrees. So here's my horizontal. We are looking down, and our angle of depression is 28 degrees. That means the angle of elevation over here is also 28 degrees. This is where her friend Arian is. They're going to meet in the lobby of Chase Tower, so Arian is going to have to walk this distance right here, so that is what we're looking for. That is x. So from this angle right here, I'm going to label my sides. Here's my hypotenuse. The opposite side over here is Chase Tower, 700 feet. And x is the adjacent side that we're looking for. So SOHCAHTOA, we don't have the hypotenuse, and it's not the part that we're looking for. We're looking for the adjacent side. So no sine, no cosine, has to be tangent. So then we would do tangent of our angle. The angle is 28 degrees. Is equal to opposite over adjacent. The opposite side is Chase Tower at 700 feet. The adjacent side is unknown. It's what we're looking for, so we're going to call that x. We want to get the x isolated, so we have to multiply by our denominator. Denominator this time happens to be x, so we multiply both sides by x. That cancels it out over there on the right. So I have x times the tangent of 28 degrees is equal to 700. And then to get the x all by itself, we're going to divide both sides by the tangent of 28 degrees. (700) divided by the tangent of 28 degrees gives me 1,316.509 feet when I round it out to 3 places. The directions said to round to the nearest hundredth. So if you had 1316.51, that would also work. Yes? On 18? Yep, let me go back to that. What was your question here? Could you do Pythagorean theorem? Yes, you could. However, the directions say to use your special right triangle rules. So that's why I did it with long leg and short leg. But without that piece of the directions, could you use Pythagorean theorem? Absolutely, you could. If you're unsure of your answer with special right triangle rules, you can always double check it with Pythagorean theorem also. Okay. What else would you guys like to see? (20B), absolutely. 20 part B. First thing I notice about this problem, in addition to the right angle here, is that it has 45 here. If I have a right triangle where one of the angles is 45, how big does the third angle have to be? Has to be 45. When you have a right triangle and one of the angles is 45, the other one has to match it. It has to be 45. So this is a 45, 45, 90 triangle. So we can use our special right triangle rules to help us solve this one. You can also use sine, cosine, and tangent. You're going to get the exact same answers. But I'm going to go ahead and use our special right triangle rules here. Because they're both 45 degrees, I know that these two sides are congruent. So that means that xy is also 82. I'm going to go ahead and write down how we got that angle, angle x. Measure of angle x plus 90 plus 45 equals 180. So then we add these two together. Measure of angle x plus 135 degrees equals 180. So measure of angle x is 45 degrees. That leaves us one last side that we need to find. We need to find our hypotenuse, xw. The hypotenuse in a 45, 45, 90 triangle is equal to the leg length times the square root of 2. My hypotenuse is xw, so that's what I'm going to put in for h, is equal to the leg, 82, times the square root of 2. So xw is equal to 82 radical 2. Again, you can do this one using sine, cosine, and tangent, but you don't have to. You can use special right triangle rules on this one. What else would you guys like to see? Any other parts of 20 or anything else at all? I have about 15 minutes left, which is enough time for at least 3 more questions. 21? Absolutely, we can do 21. Judy is flying a kite at the park. As the kite is flying away, Judy is standing 75 feet away from the point on the ground directly below the kite. So I'm going to kind of draw this over here like this. So directly below the kite would be this point right here. So this is 75 feet. Thank you. Forming a right angle here. If the kite is flying with an angle of depression of 63 degrees, okay, so angle of depression, I have to make a horizontal from my kite, and then we go down. That is 63 degrees. Alternate interior angles, that means this angle right here is also 63 degrees. What is the length of the kite string? Here's that kite string. That's what we're looking for. That is my hypotenuse. So we're looking for the hypotenuse. We do not know how high up in the sky the kite is. That would be my opposite side. But we do know the adjacent side. That's this 75 feet. So SOHCAHTOA once again. We are looking for the hypotenuse, so it has to be either sine or cosine. I can't be using tangent since I want that hypotenuse. And we have the adjacent side, so that means we're going to use cosine. So cosine of our angle, which is 63 degrees here, equals adjacent over hypotenuse. The adjacent side is 75. The hypotenuse is unknown, so we're going to call it x. We're looking for x, so we have to multiply by our denominator. So then I would have x times the cosine of 63 degrees equals 75. To finish getting the x all by itself, we need to use division. We're going to divide both sides by the cosine of 63 degrees. (75) divided by the cosine of 63 degrees gives me 165.202 when I round it to 3 decimal places. And that would have the units of feet on it. "12 minutes left. That's at least 2 more problems. What would you guys like to see? Yes.
On 32, is x and 13b a side or the other angle?
Good question, because that is one where it did not print. X is this third side right here. My apologies for that. On number 13, X is the side. So one of the ways that you can tell if something like that were to happen on the test, which I will proofread it to my best ability, that shouldn't happen on the test, but X, Y, Z letters will be used for sides, and theta or the actual angle name would be used for any angles that we wanted to find. So that is a great question, and I'm glad you asked that. Yes?
So on the word problem, when it says it must be in radical form,
Mm-hmm.
do we have any radical form when we're actually answering the question, or do we have a radical form in actual formula? I think it comes to like feet or inches.
So your radical form just means that you don't want to have it in decimal form there. So if you're doing Pythagorean theorem to find a missing piece and it says your answer needs to be in radical form, then that would be, you simplify your square root, break it down as much as you can. If it is a 30, 60, 90 triangle or a 45, 45, 90 triangle, you're going to have either the square root of 3, if it's a 30, 60, 90 for the long leg, or you're going to have square root of 2 for the hypotenuse in a 45, 45, 90. Does that help answer your question at all? Okay. So it kind of comes in through the formula, and then you would just make sure to simplify that radical as much as possible. You do have to show your process for how you're simplifying that radical, yes. For any of the problems where your answers need to be in reduced radical form, I do need to see how you're breaking apart that square root to put it in reduced radical form. 9 minutes left. That's enough time for 2 more questions, at least. Possibly 3, depending on the length of the questions. What would you guys like to see? Yes. Number 7? Absolutely. Find sine J, cosine J, tangent J, sine K, cosine K, and tangent K. All right, so I'm going to draw this triangle again so that I can circle it up and label it for both of these. So here's L, here's K and J, 30, 16, and 34. Okay, so we're going to do angle J first. So sine, cosine, and tangent for angle J. So standing here, we're going to label our sides. 34 is our hypotenuse. 16 is our opposite side. And so when I'm standing at angle J, 30 is the adjacent side. So sine of angle J is opposite, which is 16, over the hypotenuse, which is 34. We're supposed to give each ratio as a fraction and as a decimal. So I can take this fraction, I can reduce it down. What goes into both 16 and 34? What goes into 16 and 34? 2. That would be 8 over 17 if I reduce that fraction down, and then if I put that fraction into my calculator, 0.471 when I round it out to 3 decimal places. So there's sine of angle J. Cosine of angle J is adjacent. My adjacent side is 30 over my hypotenuse of 34. Let's see, into 30 and 34, 2 goes into both of those. That would be 15 over 17. When I put that into my calculator, I get 0.882. And then we still need to do tangent of angle J. This is opposite over adjacent, so 16 over 30. 2 goes into both of those. That would be 8 over 15. Or 0.533 when I put that into my calculator and I round it to 3 decimal places. So there's sine, cosine, and tangent for angle J. And then I want to do the exact same thing, but I want to do it for sine, cosine, and tangent of angle K. So now I'm standing here. My hypotenuse stays exactly the same. The hypotenuse is still 34. But now 30 is my opposite side, and 16 is my adjacent side. So sine of angle K, opposite over hypotenuse. My opposite side is now 30. Hypotenuse is still 34. 2 goes into both of those. That would be 15 over 17. That's exactly the same as cosine of angle J. Sine of K and cosine of J are the same. And then we do cosine of angle K. That is adjacent, which is 16 over the hypotenuse of 34. 2 goes into both 16 and 34, so that would be 8 over 17. Cosine of angle K is exactly the same as the sine of angle J. And then we have tangent of angle K. Tangent is opposite over adjacent. My opposite side is 30. My adjacent side is 16. So 15 over 8, or 1.875. For any of the problems where you are asked to do sine, cosine, and tangent for both of the non-right angles, I would redraw my triangle and relabel it. We have 4 minutes left. That's enough time to do one question. What would you guys like me to go over? Anything at all? If you're looking for an angle, what do you have to use? If you're looking for an angle, what do you have to use? Theta would be my unknown angle, and then we have to use inverse of either sine, cosine, or tangent. The only other possibility when we're looking for an unknown angle is if I know two angles in the triangle, I can add them together and minus it from 180. We can use our triangle sum theorem. But if I don't know any of the angles except for the right angle, then we're going to have to use either inverse sine, inverse cosine, or inverse tangent. Yes, Deborah. Number 13b. Oh, here we go. No, I went right past it. Number 13, part B. So for part B, where we are looking for x, we know two sides. Of a right triangle. How do you find the third side if you know two sides in a right triangle? Close. That's for my angles. For my sides, we have to use Pythagorean theorem. A squared plus b squared equals c squared. Hypotenuse has to be c. I don't know why I wrote plus here. That should be an equals. Hypotenuse is 18. So we have 18 squared. 15 can go in for either a or for b. And x for the other one. So we would have 225 plus x squared equals 324. That's 18 squared. Subtract 225 from both sides. You get that x squared is 99. Take a square root of both sides. On the left, the squared and the square root cancel. So you would have x is equal to the square root of 99, which we have to simplify. Let's see, 9 goes into that. That would be 9 times 11. And 9 is 3 times 3. So 3 times 3 times 11. So that would be the square root of 3 squared times the square root of 11, or 3 square root 11. So x is equal to 3 square root of 11, or in its decimal form, that would be 9.95. I do have office hours after school today if you want to come and study with me a little bit more. Have a great rest of your day, guys. I'll see you tomorrow. Thank you, Mariah.